Hello, friends of chemistry. Hi, Martin.
So,
What problem are we doing, Martin?
11.7 on page 373.
Okay, please read it to us.
In order to prevent the water in a car's cooling system from freezing, people add antifreeze to the water in the radiator. This antifreeze is typically ethylene glycol, C2H6O2. What is the freezing point of a radiator solution made from 4.00 kilograms of water and 1.00 kilograms of ethylene glycol? Kf equals 1.86 Celsius over
Molality. 1.86 degrees Celsius
Yeah.
for molality.
Okay, so the first thing we should do,
Okay.
Mom already did that.
So
Write out our
right.
formula.
So if we read the section between 11.6 and this question, we see that we're talking about freezing point depression. Okay. So what is the freezing point depression? It means that you lower the freezing point of something. Okay. We frequently use this in antifreeze, in salting our sidewalks. Okay, we're trying to lower the freezing point of the substance. So if we look on page 370, we see a useful equation. Okay, we see delta T equals negative I times K subscript F times M. So delta T is the change in temperature. Okay. Martin, what is the I refers to?
The I is the number of ions that the solute splits into when it dissolves.
Okay, and the M is the molality, not meters, right?
Yeah.
So
it's difficult to tell.
What is K subscript F?
K subscript F is the freezing point depression constant.
Okay, and its units are degrees Celsius per molality.
Yeah.
Okay, so what is the first thing that we're going to need to do?
We're going to find out the molality, or we can find out the ions.
Okay, so the molality of this is going to be easy to figure out. Let's figure that out. Okay, what is our solute?
Water, right?
That's the solvent. It's very important that we just a minute. It's very important that we understand the correct terms. The solute is a substance that's dissolved. Okay, the solvent is the liquid it's dissolved in. Okay, so the solute. You haven't seen my cousin Vinny. These Utes. He's speaking of the youths, and he's calling them Utes. It's very funny. Anyway, the solute. So we don't. How do we figure molality? Molality equals
number of moles over number of kilograms.
Number of moles of solute per number of kilograms of solvent. Okay. So the solvent here we know is water. We know how many kilograms we have. We have 4.00. How much solute do we have? We have 1.0 kilograms. Let's figure out how many moles is that, because that's what we need to know in order to figure out the molality. How are we going to do that?
Yeah, we need the AMU of.
Correct. We need to figure out the weight of a mole of C2H6O2.
Well, oxygen is easy. That's 16.0.
Yeah. What's carbon?
12.0.
So.
Hydrogen is 1.01.
We've got 24.0 plus 6.06 plus 32.0. What am I going to have to do here? I have 62.06.
I think.
What are my rules for adding and
moles over?
Excuse me. What are my rules for precision and adding?
We could only use the tenths.
So what am I going to report as?
62.1.
62.1. I actually have to round up here. Okay. 62.1 grams per mole. Or 1 mole per 62.1 grams. Which one am I going to use to find out how many moles of this I have?
The grams over mole.
No. I want to find out how many moles I have.
Okay.
But wait a minute. Let's look at this. This isn't grams yet. Let's make it grams. In order to make this grams, we should say 1.0 kilograms times 1,000 grams per kilogram, right?
Yeah.
So we have 1,000 grams. How many significant digits should we remember that the 1,000 grams has?
1, not 2.
That's 2. Okay. So we have 1,000 grams. Now I'm going to multiply it by the correct conversion unit to find out how many moles I have. Which one again?
It's the
moles per gram. Okay, times 1 mole per 62.1 grams. Grams cancel. Now we divide 1,000 by 62.1. Please do the honors on the calculator.
It's 16.10305.
16.103. Okay. So we have 2 significant digits in our grams. Remember 1 and 0 and 3. So we want 2 here. So we're going to say 16 moles, right? Yes?
Yeah.
Okay. So we have 16 moles of this. So now we can figure out the molality. We're going to divide 16 moles divided by the kilograms of solvent, which is 4.00. Which is 3 significant digits. 14 is 2 significant digits. 2 significant digits. Reported as 4.0 molality. Right?
Yeah.
Okay. Look at the substance C2H6O2. What do you notice about it? What kind of a compound is it? Is it a covalent or an ionic compound? It is a covalent compound.
It's got 1 ion.
Right. Okay, so there's no metal present. It's not ionic. It's not going to split into ions. It's going to dissolve 1 molecule at a time. So the I, the number of ions or molecules in this case, is 1, right?
Yes.
So let's look at the delta T here. We've got -1, right? Times this, which we know, 1.86 degrees Celsius per molarity, times the molality, which is 4.0. Okay, so the molality will cancel. The units of the I is just, there are no units. So we'll end up with degrees Celsius, which is what we want. So it's going to be somewhere around 8 degrees. Will you figure out exactly what it is for us? Remember, this is going to be a negative number because we're multiplying by -1.
Okay.
So you multiply 1.86 times 4.
1.86 times 4. 7.44.
Okay, and so we're going to report 2 significant digits. So write -7.4 degrees Celsius. So that is the change in temperature, right?
Yes.
Are you sure you got 7.44?
Yes.
They're reporting too many digits. Haha, it's their fault.
We win.
We win. Okay. So where did I get my 7 point? So that's the change from what? What's freezing?
0 degrees.
0. So the freezing point, instead of being 0, is
0.
negative
Negative
7.4 degrees Celsius. What is negative 7.4 degrees Celsius equivalent to in Fahrenheit, in order just to think of it? Go look over there at the thermometer that we have that has Fahrenheit and Celsius on it together. We'll be right back. It's close to negative 25 degrees Fahrenheit. So that means that ethylene will keep things unfrozen to about negative 25 degrees Fahrenheit, which is pretty cold. Okay? So negative 8 degrees Celsius doesn't sound as cold as negative 25 Fahrenheit. But that's what it means. We often don't understand what Celsius means because we don't use those units regularly. Okay, that's it for 11.7. We'll come back with a separate video for 11.8.